Hello everyone, this is Srikar and I am going to present on the topic of object detection using YOLO V8 and Streamlit. This is my project for Data 606 capstone at UMBC under the guidance of Professor Chao Ji Wang. Introduction to YOLO V8 and object detection. YOLO, a state-of-art object detection model. Object detection is a fundamental task in computer vision with numerous real-world applications. YOLO V8 is a highly efficient and accurate object detection model that can process rapid images rapidly. It enables the identification and localization of objects in images and videos, powering a wide range of technologies. To the data collection, which is the main part of this project, I am using the COCO dataset to train my model. So, COCO, as we all know, COCO dataset is a widely used benchmark for object detection and research. So, I downloaded the COCO dataset directly from the original website. It contains over 200,000 labeled images with 80 object categories in total. So this is the format of COCO dataset. It contains three files. One is the train.zip, which contains the training images, validation.zip, which contains the validation images, and annotations.zip, which contains the annotations for both training and validation sets. So let's learn about the COCO dataset. It consists of image annotations. Each image has labels and bounding boxes around objects, object categories. It covers a wide range of everyday objects, and also the dataset includes wide. It's actually very diverse, and as it contains various settings and backgrounds. In addition to the bounding boxes, some images have pixel level segmentation marks for instant segmentation. Data subsetting is the main part of the whole project, as COCO dataset is very large, as it contains 200,000 images, and since we have limited computational resources, we have to subset it whole data. So this is actually main important because of the need for faster experimentation during the model process. Training on full COCO dataset may be computationally intensive, especially on resource-constrained environments. So I used about 10% of the actual data and stored that into the Google Drive, which was actually accessed through Google Colab. So this is the statistics of my subsetted data. It has around 6,000 training images, 1,000 validation images, and all the 80 categories from the original dataset. COCO annotations is the place where it contains all the information about each image, the bounding boxes and all. So here is the structure of COCO annotations. Uh, in the images uh, key, it contains all the images uh, in the dataset, and the annotations contains the information about bounding box and the category information for annotated objects. And the categories key contains definitions of all the 80 objects categories in the COCO dataset. These are some of the sample images from the dataset and their objects inside that. These bounding boxes are drawn using the PAL library using the coordinates from the annotation data. Converting COCO format to YOLO format. This is a crucial step. Converting dataset from COCO format to YOLO is required. As YOLO expects the training data to be in this format. So this is how we need to format the data for it to train on the YOLO model. So we should have the two directories, images and labels, and also a coco.yaml file which contains the paths of these images and labels. So inside each image and label there should be two directories named train and validation. After training the 6,000 images on the YOLO V8 model, here are the metrics. Coming to the training metrics, the best model is at the 100 epochs, where it has the highest precision of 0.61 and also the validation precision of 0.60. Although we trained for more epochs, the precision went down, indicating the overfitting of the model. Here are some of the predictions with the YOLO V8 after the training. Here we can see that the 8 plane is detected, the stop sign is detected, teddy bear is detected, and also person is detected, clock is detected, train is detected. Here are the next steps. Currently, the model is able to detect both images and videos and can be extended to include live camera and YouTube links. And the next steps also includes deploying the web app to a cloud platform or using the Streamlit deploy. Training with a large dataset to improve performance. Now let's see how our web application using Streamlit works. So this is how my web application look like. It has the option to upload image or a video file. It also has the option to filter out the objects that the user requires. So if the user requires only to detect person, bicycle, and car, he can just select person, car, bicycle here with the confidence score, whatever it might be. It's the slider from 0 to 1. So if this user wants the person, car, and bike to be with a confidence score of 0.5, he can just slide it to 0.5, browse the file, and click submit. So for the demo purpose, let's say if I include the bicycle with a confidence score of 0.3, uh, and click on submit here. So even though it contains dog, car, and the bicycle here, it only detects bicycle because we asked it to only detect the bicycle. So let's say for the same image, I include dog and keep the same confidence score. It also detects dog with a 0.91 confidence score and the bicycle with a 0.89 confidence score. So let's try with some other image. Let's try with giraffe. And let's say I want to select giraffe with a confidence score of 0.31 or whatever it may be, 0.4. Click on submit. So here it shows even though it has multiple giraffes inside the image, it successfully detected each of the giraffe in the photo. Let's say if here the giraffe has 0.62 confidence score, and I want to filter out that. Maybe if I keep it 0.7, so these two giraffes should not be identified. And yes, that happens. So only the only the object with more than 0.7 confidence score will be shown. So since this giraffe has a confidence score of 0.83, this will be shown. And let's select a video file. Here I have a dog video, and let's see if it detects a dog. It also has a person in that, so I'll also include person in the drop down here with a confidence score of maybe 0.1, and click on submit. So it shows it processing the video. So here we can see both the dog and the person are getting detected. So it actually the model actually process the video file frame by frame. So since we asked, so it also detects the persons at the back. So that's it from my web application. And these were some of the references I used, which includes the YOLO V8 Ultralitex original GitHub repository and their official documentation. And thank you.